If you're building a distributed engineering team and you want to hire the best and the brightest from around the world, you're going to want to listen to today's episode with Vijay Krishnan, CTO of Turing.com. Welcome to the Productive AI podcast, where we aim to simplify AI and make it more accessible to business leaders. I'm your host, Troy Angrenon, and today we're talking to Vijay about what he and his co-founder are doing in this rocket ship company they're building to help provide fantastic, interesting engineering jobs to folks all over the world. Vijay, thanks for coming on the show.
Thanks, Troy.
Also, at the end, what we're going to do, I've already given Vijay a little heads up on this. If you stick around, I'm going to ask him at the end for his thoughts on advice to AI company entrepreneurs and founding teams, given that he's building a company with a huge AI focus, as well as what to think about if you're interested in being in the engineering side of an ML or AI career, and how to think about developing your career in that space. He has a long history in the space going all the way back to 2007 before ML was cool. So we'll talk about that at the end. Before we get there, let's dive into the meat of the conversation. So now, Vijay, I kind of just touched on it, but you have an extensive background. You started in ML way before it was cool back in Yahoo in 2007, 2008. Did you sort of plot out your career and end up here, or do you look backwards from here at all the steps and say, those things led me here and this is how I got here? So I'm curious about, the path you took and how long you've been in the field and how you arrived at this company.
Yeah, great question, Troy. So I don't know that I I did believe AI would be big, but nobody could have quite predicted necessarily that this 2012, 2013, basically the reboot of neural networks by way of deep learning would take AI to a whole new level. In fact, I think my earliest entry into the field of AI was back in my undergraduate days, back in 2003. I had started to write some strong papers on the applications of machine learning in different conferences like SIG-IR, EMNLP, and so on. So at that, I would say until 2007, I was doing this both back at IIT Bombay and at Stanford University as an AI researcher, really. As you said, 2007 onward, I started applying this to problems in the industry. I think personally, I like I have always been a lover of probability and statistics, which is so much at the foundation of a lot of modern machine learning. And it just happened to be something that I loved, I was good at, and that seemed to have some practical value. I didn't know it would be this much practical value at that point.
And then now, where did you go from Yahoo?
So I was a scientist at Yahoo in their machine learning team, applying ML to problems in text categorization, personalization, and so on. I started my previous company, Rover, soon afterward. So we started off doing personalized search. We did that for a certain period of time, and then later moved into the space of personalized content discovery instead. So I ran that company for a while, and that company got acquired about 4 years back. So when it came to personalized content recommendations, what we did was we based on your past web browsing data, we would build deep user profiles the same way Google and Facebook builds deep user profiles, and we would use that to recommend other content that you may like. So a lot of machine learning went into categorizing your content, figuring out what your interests are, then doing the same when it came to new novel stories. At that point, we had to both figure out topicality of different stories as well as how interesting they would be. Ideally, you want a story that matches your interests as well as is interesting in absolute terms.
And you had some huge reach. This was Rover, which was acquired by Rev Content, and if I remember, it was something like 1.5 billion users monthly or something. Like, it had huge scale.
That's right. That's right. So that's right. So Rover itself got to 40 million registered users, and I think after our acquisition by Rev Content, we certainly got to reach a much larger scale applying our technology to Rev Content. So Rev Content certainly saw billions of over a billion monthly unique visitors across a whole range of their publisher partners. It was very exciting to deploy our personalization technology to data of that scale.
Excellent. That makes sense. Now, where does the now you as we said at the beginning of the call, you're an ML guy from way back in the day. You've been doing this all the way from school, actually. Is there real machine learning and AI, if you want to go there, or any of these kinds of tools? Do they truly exist inside your platform? And if so, kind of what does that look like?
Sure. So we use it in a number of places, but I'll talk about some of the most exciting and the most impactful places where they play a role at Turing. I would say it is really in the building of deep developer profiles as it relates to which in turn helps us make much better quality matches and even helps us improve our tests itself. So today we think of the whole problem of developer testing and interviewing as a machine learning problem. Really, when a software developer from this country signs up, we don't know anything about them. A priori, we think there's a 1 to 2% chance that they would be matchable to a customer. Now, then the way we see it is the job of our tests is to be as efficient as possible. And in a sense, if the prior probability is like 1%, can we either move it? Can we make sure that each minute of that we spend testing a developer helps us rapidly move that probability estimate either upward or downward? Either go towards 0% or go toward 100%. Don't waste a developer's time with something that doesn't quite give you very much signal. And the nice thing now is that because we are because we are a nice sort of vertically integrated solution that goes all the way from sourcing, vetting, matching, and even collaboration after the match, even rematches, all sorts of things like this. We have access to all sorts of data that very many players don't. Like, for example, there are companies that have a SaaS solution for administering programming tests, but they don't have a full cycle data that provides any kind of machine learning based trained data regarding what is actually important. I mean,
these would be traditional, as we talked about, traditional staff aug companies that if you said to them, hey, I want to instrument the apps you're using for testing, pull all the data off, spin it into a database, and then actually use that as part of our deep neural network, they'd say, I don't even know what you just said to me.
Right. Yeah.
Okay. So you're basically saying, look, we own this whole process from start to finish. Let's pull off as much data as we can and run it through the tooling that we know.
Right. Yeah, because we also have a lot of nice end-to-end data with regard to, I mean, almost in machine learning parlance, I would say it is ground truth labels. So we can look at all the successful developer collaborations at Turing. We can look at the handful of unsuccessful ones. We can look at other ones where we placed a developer before a customer, but the customer said, well, I talked with this person. I don't think the match is quite right for reasons ABC. This person is not quite it. Now, all these serve as kind of, you can say, positive and negative training examples. And this helps us in turn tell us what is even important from a vetting perspective. What actually predicts success, in a sense. What predicts success? What what is an unnecessary...
You're doing feature engineering here. You're basically, you're really just using all these inputs and all these outputs as you said, training data to make the system better at matching.
That's exactly right. And today hiring is just it's just a matter of like religious debates. VPs in some company believe this is the right way to vet. Some VPs in other companies disagree. We can try everything and we can figure out what predicts success with what kind of customers. I mean, there are certain kinds of customers where perhaps algorithm skills and data structures and all that really matters. There are other kinds of customers where specific knowledge of your tech stack and being an excellent communicator and having product sense and things like that tends to matter. So
there would be no universal algorithm that could predict the best person for all companies, and I'm sure you must end up segmenting your companies into small clusters or clustering them into small clusters where they have you would want similar people for them to achieve certain attributes or whatever.
That's absolutely right. Absolutely.
And
And and it's
then
amazing to
what?
see so many of our so many of our earlier intuitions even occasionally pretty much disproved by our end-to-end data that
Yeah.
like Jonathan and I guess our Stanford grads have worked with the I mean, we have seen a lot of the hiring processes at the Googles and Facebooks of the world. Our VP of engineering used to be a former eng manager at Facebook as well, managing a large team and everything. So we brought in certain ideas with regard to what is important. But it was very eye-opening to see what actually matters, how maybe a notion of who is successful uh, doesn't perfectly match our intuition.
That is super cool. And I always laugh because I've had this conversation a lot and people say, oh, AI is so terrible because it's so biased. And I say, have you seen any process run by humans lately? Because they're all terrible.
Right. Yeah. I think that's absolutely right. I mean,
We're the worst version of bias. Machines will probably be a step up from where we are.
Right.
Excellent.
I have seen. In fact, it's funny. I actually had exactly these kind of discussions with so many AI startups, and I've had this conversation so many times where I asked, well, isn't this a really difficult problem for AI to solve? Yeah, and they asked, do you know what the humans we are competing against are actually producing today? And all we have to do is beat that. We don't have to build a perfect AI.
That's right. We have to have 10 times less bias than the humans. And then, frankly, that's
Yeah,
probably a pretty low bar.
that's true.
All right. So let's talk about where you guys are at, because you guys just raised another round, I think. So where are you at in terms of stage of the company and funding and all that? If you are an engineer and you want to get into the space, or you're just at the beginning of your career, any advice for those folks? Because you've had a long and super interesting career in the space.
You're talking AI specifically?
Yeah, ML, AI, let's say specifically, since that's kind of the focus of the show here.
Perfect. Yes, I do have some thoughts. So here again, I'll share maybe what other people are less likely to say, but I
Sure.
believe to be true, since
Yeah.
that is what would be most valuable. So here, I would say one of the things that is just not done enough is really understanding the fundamentals, understanding the mathematics, getting enough of a solid grounding in the probability and the and statistics and all that stuff. Like, I think one of the major problems I see with this thing, with the state of machine learning talent, and I guess the what is getting common is a lot of the well, it seems to be widely believed that the way you become an AI engineer is you don't need to know any of that stuff. You don't need to know what any of these things are doing. You don't need to know how models work. TensorFlow has all that stuff figured out. All you need to do is download TensorFlow, upload a few data sets in it, tinker with it a little bit, and you become an AI engineer. No, the degrees of freedom are just too many. I think there is a sense in which the kind of things you can bring to bear that can make you unlock enormous amounts of effectiveness and efficiencies grow dramatically if you really understand the mathematics behind the stuff, the fundamentals of what the model is doing. What
Mm-hmm.
does this optimization even look like? Like, for example, if the sort of thing that actually even happens in machine learning classes at Stanford or other top universities, the sort of thing where you write your own toy training algorithm. At least you sort of understand what this is doing. You understand what gradient descent is. You understand what the model's constraints are, and so on. So I would this is by far I think the area where I would suggest that more people spend time. And this apart, of course, there is the other angle, the practical angle of this, that you never want to be doing AI for AI's sake. You always want to understand enough business and product. You always want to make sure you're doing like the simplest possible thing that is also maximally effective. You want to put that hat on always. The more
Right.
complicated you do something, the harder it is to extend, the harder it is to draw lessons from that, the harder it's to debug, uh, or odds are maybe you'll have a harder time even getting it past the production team. They may be like, well, your model size is too big, your this it hogs too much memory, it's going to be a
Mm-hmm.
nightmare putting it there, here and there. So yes,
Right.
you do want to understand a lot of those aspects also. So a lot of the pragmatic aspects of it, you need to have this extreme bias toward simplicity and effectiveness at the same time, and really really understand the underlying mathematics. Otherwise you're very handicapped. I mean, you're kind of, you're walking in some dark alley with nothing to guide you in the right direction.
Yeah. And I think that this is essentially what I'm hearing from you is learn the primitives, learn the foundations, learn them well, and then you can go for the easier tools that sit above it because you know what those tools are doing. You know if they're working, you know if they're going off the rails or leading you astray. But if you don't have that foundational knowledge and you're using those mid-level, let's say middleware type tools, you're just pushing buttons at that point. And if
That's
it
right, that's
goes
right.
and it breaks, you have no idea. You have nowhere to go at that point.
Yeah, yes, absolutely. I mean, I wouldn't. I don't know if I would necessarily say do this first versus that, but make sure to understand that this is an important hole that has to be filled first. Even if you started tinkering with the tools first, understand that to become a really effective ML engineer, they assume their job is done. I'm doing.
Yeah.
I know everything an ML engineer needs to know, and
Yeah.
while nothing could be farther than the truth.
What's interesting about that advice, and I've heard this on a couple of my other calls, is you're both telling them to go deeper as well as to go up, and depending which way you draw that stack, but to go down into the foundations of machine learning, but also to think between the up into the product space and then into the business space, and be one of those engineers who doesn't just say, great, I love building stuff, I'll build that, but comes back and pushes back potentially on the product team or the business team and says, we don't need machine learning here, we don't need AI here, we can do this far faster and far simpler if we take a different track.
Mm-hmm.
And that is such an undervalued skill. So I love that you kind of took it in two directions there.
Yeah, absolutely. Because those things go so well together. I mean, often business doesn't quite understand what AI can do. They don't have the full picture. If the
Right.
AI people don't quite understand what's important there either, you always have this disconnect. And we have all seen this. We have seen so many of these companies doing these massive investments in AI, and with nothing to show for it.